Assalamualaikum and good morning. Okay, today I'm going to talk about learning outcome 3.4, that is electromotive force. Okay, what is electromotive force? Electromotive force, or EMF, is defined as the energy provided by the source, battery or cell to each unit charge that flows through the external and internal resistance. So what we can see from the picture, we know that EMF is providing energy to each unit charge that flow through the external and internal resistance. Okay, when the current I flows naturally from the battery, there is an internal drop in potential difference or voltage equal to IR. So terminal voltage V is less than EMF due to internal resistance R of the battery. So this is the equation for the electromotive force. And the unit for the both EMF and voltage are volt. Internal resistance. What is the internal resistance? The resistance of the chemicals inside the battery between the poles, and the symbol is R. The smaller the internal resistance for a given EMF, the more current and the more power the source can supply. Internal resistance can behave in complex way. As noted, R increases as a battery is depleted and electrolyte dries out. But internal resistance may also depend on the magnitude and direction of the current through a voltage source, temperature and type of chemical material in the battery. So, what is the factors that affect the internal resistance of cell? First is temperature of the cell. As the temperature increases, the mobility of ions increases inside the electrolyte, so internal resistance decreases. Second, chemical composition of the electrolyte. The greater the conductivity of the electrolyte, the lesser the internal resistance. Next is separation between the electrolytes of the cells. As the separation increases, the current has to flow through longer distance between electrodes and increase the internal resistance. This is the symbol of the EMF and internal resistance in the electrical circuit. It can be this or this. Next, we go to the terminal potential difference. So, terminal potential difference or voltage is defined as the work done in bringing a unit or fast charge from the negative to the positive terminals of the battery through an external resistance only. So this is the formula for terminal voltage, that is V equal to IR, where I is a current flow in the current and R is the total external resistance. So we can, from the figure, we can know that voltage needs or EMF equal to 3 voltage, and terminal voltage equals EMF only if there is no current flowing. Next, the figure shows that voltmeter leads EMF 2.5 voltage. So the internal resistance R of the voltage source affect the output voltage when a current flows. You must remember that smaller the internal resistance R, the greater the current the voltage source supplies to its R. So we move to the question or example. Okay, a 12 volts battery has an internal resistance of 1.5 ohm. It is connected to a 6.0 ohm resistor. So the question 1, what is the current in the circuit? So we know that current is I. So we want to find I. And then the question given it's EMF equal to 12V, R equal to 1.5 ohm, and resistor is 6.0 ohm. So we have the formula over here, so we just input the information to the formula. So we know that EMF is equal to 12, and we want to find I, and 1.5 plus 0.6 So we calculate and we got 1.6 ampere. Okay, that's the answer. Okay, next we move on to the what is terminal voltage of the battery. Okay, so the question wanted V. So we have a formula that is V equals to I R. Okay, so we got V over here, we got I over here, and we just input it, and R is 6.0. So we calculate and got 1.6 voltage. Okay, that is the answer. Thank you.